To demonstrate a proof now on existential elimination. So this is a forward type of step in natural deduction for predicate logic. And what we're doing is eliminating an existential quantifier in front of a formula here. And so in the top, we have exist x, p of x and q of x. And we know that if we could just sort of take off that quantifier exists x, we can separate the conjunction and then put the quantifier back on. So that's kind of the reasoning that's going to happen here. And so in a forward step, if we do an existential elimination, it doesn't require any additional variable. It's not like an existential introduction, for example. It's going to introduce a variable for us. So it creates this actual I, and it says that because there exists some x where this holds, let's call that xi, and we know now that p of I and q of I holds, and we need to be able to prove there exists an x of p of x. Now the existential introduction, right, if we were to look at the point in step 3, this requires a backward step to introduce, and it needs a variable for this. And so we're going to be using the actual I that we've just created here, and we want to use that same variable substitution. So in a backward step, we can do the existential introduction, and we now get p of I. Now, the only step that remains for us is to use our standard propositional logic to break apart this conjunction. And so we'll use a forward step, conjunction elimination, preserve the left, and we now have pi from up here, and this ties together both ends of the proof. So again, when you're doing existential elimination, it doesn't require any existing variable to sort of unify with. It's going to create that variable for you, and you'll have an assumption box that you need to finish and complete the proof. So that's it for now. In future videos, we're going to see some more complicated examples of mixing all of these things together.